discussing about QueueStacks. Before going to QueueStacks, let's first learn about queues and stacks.
So what is a stack? A stack is a last in first out data structure. This means that the last element to be added to the stack is the first one to be removed. Think of a stack of plates. When you add the plate, it goes on the top, and when you remove a plate, you take the topmost one. Let's see an example. As you can see in here, there's an empty stack. We push an element, then we push another element, and that goes on the top. We push another element, which is the topmost element. Then when we remove an element, we take out the topmost element. This is another example, stack of books. When we keep enter and book, we keep it on the top, and when we remove a book, we take the topmost book. Now let's discuss what is a queue. A queue is a first in first out data structure. The first element to be added is the first one to be removed. Think of a queue at a bank. People join at the end and leave from the front. As you can see, this is a queue. We enqueue. Enqueue means insert data from here and output data from here. As you can see, this is the bank example. The first person to be added to the queue is this person, and she does her work, and she is removed first. So the first person to be added is removed first. First in, first out. That's how this data structures operate.
Let's see how a QueueStack operates. First of all, before moving on to QueueStacks, you should know that this side is the input, this side is output. In every queue, the input is this side, the output is that side. First, let's discuss about push-fill QueueStacks. We'll use the same elements as above. Let's push 3. This is the push queue, this is the pop queue. I have labeled every queue in the board. When you push 3, we input from this side and 3 is inserted. Then we will push 5. Push 5. As you can see, 5 is the top element. So we have already inserted third element. So when we input 5 from this side, 5 is situated here. Then let's input 7. Push 7. Since 7 is the top element, it should lie above the fifth element. So 3, 5, 7. So this is the push queue for now. Now we need to pop an element. Since this is a push-friendly QueueStack, even though to push an element we need only one step, to pop an element we need 3 steps. The first step is there's already 753 in queue, push queue. So the element we are supposed to pop is the top element, which is the 7. We are supposed to pop this element. So keeping only that element in the push queue, we move the rest of the elements to the below queue pop queue. So when we insert those remaining elements like this, that's the first step. So the second step is we swap the names. So as you can see, this is how the push queue and pop queue works. So we swap the queue names. So the queue with remaining elements become push queue, and the queue with 7, which is the top element, becomes pop queue. Since in a pop queue we can directly pop an element, so we'll pop this. Now let's move on. As you can see, the next step is to push number 9. Push 9. As the push queue is below, we have already 3 and 5 in the queue. Then we'll push 9th element. When we push 9, 9, 5, 3 is the push queue. Then we have an operation to pop again. For popping, we again need 3 steps. So keeping the top element, we'll move the rest of the elements to the pop queue, which is 5, 3. Then keeping that element, we'll swap the names. So the queue containing 5, 3 will be push queue, and the queue containing the top level element will be pop queue. Since it is pop queue, we can directly pop this item. Then we need to perform the pop function again. It will be same as before. This is a push queue. We insert these elements. Since we need to pop the top level version, which is top level element, which is 5. We'll just keep 5 here and move the remaining element to the pop queue. Then we will be swapping the queue names. So the pop queue will be, the push queue will be a pop queue, and the pop queue will be a push queue. Since this is pop queue, we can directly pop the elements. Now that's how a push-friendly QueueStack operates. Now let's discuss how a pop-friendly QueueStack operates. You should always keep in mind that in a push-friendly QueueStack, it is easy to push an element. In a pop-friendly QueueStack, it is easy to pop an element. So we'll use the same operations as above and same elements. So the first step is to push 3. We'll be doing that. Push 3. So this is a pop-friendly QueueStack. Pushing an element requires 3 steps. The first step is to push the element in the push queue. So when we are pushing 3, so we'll put 3 in the push queue. Then the second step is, if there are any elements in the pop queue, we should insert them into the push queue. Since there are none, we don't need to do that. Then we should swap the names of each queue. So the push queue becomes pop queue and the pop queue becomes push queue. Again, we need to push an element. We need the before mentioned 3 steps again. We should push 5. Push 5. The first step is we should insert the element into the push queue. 5. Then, if there are any elements in pop queue, we should insert them into the push queue. When we check, there is already an element in the pop queue, so we should insert it into this push queue. We have already 5 in this queue, and when we insert 3, this queue becomes 3, 5, and this becomes empty. And the last step is we swap the names. Pop queue becomes push queue becomes pop queue. And again, we have to push an element. We require the same steps mentioned before. We already have 3 and 5 in this push pop queue. We need to push 7. Push 7. We'll put 7 here. If there are any elements in the pop queue, we should insert them. We already have elements, so 3 and 5. 3, 5, 7. And we swap the names. Pop queue becomes push queue becomes pop queue. Then we have a pop function. Since this is a pop friendly queue, popping an element only requires 1 step. So we already have 3, 5, 7 in the pop queue. As you can see above, when we pop an element, the top level element should be removed. Since in a queue, this is the input, this is the output, we can simply just pop this element. Then we have one push element, push operation. We'll push 9. We already have 3 and 5 in the pop queue. We'll push the element in the push queue. If there are any elements in the pop queue, we should insert them. Then we swap the names. 3, 5, 9. This queue becomes pop queue, and the pop queue becomes push queue. Then we have an operation pop an element. We can simply just do that. 3, 5, 9. We simply pop this item since this is the way of the output. Then we have another pop function. 3, 5. We can simply pop that also. So that is how a QueueStack operates. As you saw, this is push-friendly QueueStack, this is prop-friendly QueueStack. That's how these data structures work.
Okay, now let's move on to the coding part. Here I have a code of a stack. As you can see here, I have created a new integer stack and I have pushed some elements 10, 20, 30. As you know, the last added element should be the top level element because this is last in first out algorithm. Therefore 30, 20, 10 should be the stack. Now let's run this code and determine whether our code is correct or not. Okay, as you can see here, the stack is printed 10 and the top level element remaining is 20. So therefore the code is correct. Now let's move on to the queue code. This is the code relevant to the queue. As you can see here, I have created a new queue here and added few elements. Added the elements same as before 10, 20, 30. Now let's run this code to determine whether our code is correct or not. As you can see here, 10, 20, 30 is displayed in the queue. Then we use the queue poll function to remove an element, and the removed element is 10, which is the first element we enter to the queue. Therefore, the front remaining element should be 20. As you can see here, this code works correctly. Let's move on. Now let's discuss the code for QueueStacks. This is a stack made by using two FIFO queues. A FIFO queue is a first in first out queue. This stack provides basic queue operations. And now let's discuss the code. This is a constructor. As you can see, this is code used to enqueue an element, and this is to dequeue an element. This code is used to peek at the front element. These are just simple functions that can be easily understood. Check if this is used to check if a queue is empty. This is to override to string to display elements in the queue. As you can see, this is stack implementation tool using two FIFO queues. This is the Q1, which I like to call the push queue, and this is the second queue. This is the construct of that. DT is used to put an element onto the stack. This is used to open top element from the stack, and this is used to peek at the top element without removing it. This is to check if the stack is empty, and this is the override command. As you can, this is the main function. In this, we introduce a new FIFO queue, and this is used to enqueue element. This is display the queue. This is dequeue the element, and this is to display the stack. Now let's run this code. As you can see the initial queue and the front element, then the initial stack and the top element. In the queue, the front initial element. So yeah, this code works perfectly fine. Now you can understand how QueueStack works.
So now you know how QueueStacks and QueueStacks operate. If you have any question, please make sure to drop a comment. If you want more coding tutorials like this, please make sure to like and subscribe. Thanks for watching. See you in the next video.